Let's do worksheet number 2 for the radicals. Fourth root, so we're taking out groups of 4. This is an even number, so 2 must go into it. 2 times 81 is that, so 81 is 9 times 9. 9 is 3 times 3. The other 9 is 3 times 3. X third, Y fourth. We're taking out groups of 4. So there's 4 3s will come out as a single 3. A 2 will be left in. X to the third, that's 3 x's multiplied. Can't take those out. Can take the y out because there are 4 of them. It's an even root. If it's an odd power coming out, we need absolute value. And we have the fourth root of things that didn't come out, which were 2 and x to the third. Odd root, the negative comes right out. X 3 times, so it comes out as an x. Odd root, so we don't need absolute value. Groups of 3. This is 2 groups of 3. That's y squared. Done. Everything came out. Even root, the negative doesn't come out, so the negative and 2 is a single, so it won't come out. So we're going to have a square root of negative 2. Don't need to put the 2, but I will. X to the fourth, 4 of them will come out as 2 x's, so that's x squared. It's even, but since this is squared, I don't need the absolute value. The y squared comes out as a y. That's an odd power, so we need the absolute value of y. On this one, it's a square root, means pairs. So 12 is 4, 2 times 2, times 3. 4 times 3 is 12. And so we got x squared, y, in the square root. A pair of 2's come out. 3 stays in. A pair of x's come out as a single x. That's an odd. This is an even power, so even root, so we have to do absolute value. The y doesn't come out, so what's left inside? We took the 2's out, the x squared out. 3y is still inside. We already pulled, this has a 4 and an x already pulled out. It'll be times whatever else we can get out. 28 is 4 times 7, and x, 4x is multiplied, square root. Pair of 2's will come out times the 4, makes 8. This 4x's, each of pair of them will come out as an x, so that's x squared. Even, x squared is okay. We don't worry about this one being odd, so we're bringing out an x squared to multiply by the x, so we get x to the third, no absolute value, and the 7 is what's left in the square root. Okay, we're adding, so we can't put these two things underneath the same one, but 8 can be brought down. That's 2 to the third. So a pair of 2's will come out, and there'll be a 2 left in. So we're going to have 3 times the square root of 2x plus a 2 will come out and be 2 times the square root of 2x. And this happens to be identical to this, so we have 3 of these things plus 2 more of these things, so we have 5 of the square root of 2x's. You could factor it out and have 3 plus 2 times the square root of 2x, and then add them, and you get 5 square root of 2x. These are multiplied, so we could put all of these under one square root. They're the same root sign, so we can put it all under one. 48 is 4 times 12. 12 times 4 is 48, or 16 times 3 is 48, or 6 times 8 is 48, whichever way you want to do it. That's the 48. We have a 3. X times x is x squared, and a y squared. Square root, so we're looking for pairs. One pair of 2's, 2, and a 3, so that's 2 times 2 times 3, which is 12. Pair of x's will come out as an x. It's an even roots, odd number, so we need absolute value. And same with the y, we can put both of those in one absolute value. Then we have cube roots, same roots, so we can put those together. That 3 is not on the x, not the power of x, it's in the root. So this is, we have a 3 and an x already out, and we have the cube root of 3 and 27 is 3 3's multiplied, so we have a total of 4 3's, 3 x's multiplied, and y twice. So 4 3's, 3 of them will come out on a cube root times and be a single times the 3, so that's 9. 3 x's even are odd roots, so don't have to worry about absolute value. It'll be an x times the x that's already out there. And the y squared, can't bring it out because there's not 3 of them. And we had 4 3's, there's 1 left, so we're going to have the cube root of a 3y squared. Next one, no roots on that, so that's okay. Square root of a 4 is 2. An x still left inside. And 27 is 3 to the third, so we got 3 3's. We can take 1 out. Leaves the cube root of x. This is square root, this is cube root, so we can't factor it out and combine like terms. There are no like terms, so we're done. Odd root, so a negative comes out of an odd root. 27 is 3 to the third, so it'll come out as a 3. We're done. Odd root, negative, so the negative will come out. 81 is 9 times 9, which is 3 times 3 times 3 times 3. So we're looking for 5. That's not 5, so we're going to have to leave the 81 inside the fifth root. And y 8 times multiplied, that's 5 of them will come out as a y odd root, so we don't need absolute value. Leaves 3 of them in. Page 2. So we have 2 to the 1. 2 squared to the x plus 1, and that 16 is 2 to the 4th to the 3 minus x. So there's a common base of 2 in all these. You need to be able to recognize that. And when you got a base to a power, you multiply the powers. So we got 2 to the 1. 2 to the 2x plus 2. And we have 2 to the 12 minus 4x. When you're multiplying like bases, you add the powers, so you have 2 to the 2x plus 2 plus 1 more plus 3 to the 12 minus 4x. The bases are now equal, so the powers must be equal if they're equal. So 2x plus 3 equals 12 minus 4x. Add 4x to both sides. Subtract 3 from both sides. And we get 6x equals 9. And x equals 9 over 6. 3 over 2. 3 goes into both of them. Or 1.5. Next one. 25, 1/5, 125. Common basis 5. This is 5 squared to the 2 minus x. 5 to the negative 1. And 5 to the third is 125 to the 3x minus 1. So we multiply these powers, so we get 5 to the 4 minus 2x equals 5 to the minus 1 times 5 to the 9x minus 3. And when you're multiplying two terms like bases, you add the powers, so we get 5 to the 9x minus 3 minus 1 more minus 4. Same base, they're equal, so the powers must be equal. 4 minus 2x equals 9x minus 4. Add 2x to both sides. Add 4 to both sides. 8 equals 11x. X equals 8 divided by 11. Looks like the common base is 3. This is 3 to the third to the x times 3 squared equals 3 to the negative x squared. Take care of this first, so we got 3 to the 3x times 3 to the 2 equals 3 to the negative x squared. So we add here, so we got 3 to the 3x plus 2 equals 3 to the negative x squared. Like bases, equal, so the powers have to be equal. So 3x plus 2 has to equal negative x squared. When we have squareds and x's, we want to set it equal to 0, so I'm going to add x squared to both sides. And I get a quadratic, x squared plus 3x plus 2 equals 0. Use the quadratic formula or factor. So x must equal negative 1 or x equals negative 2. And finally, 8 is 2 to the third, 4 is 2 squared, so 2 is going to be my base. 2 to the third, but it's in the denominator, so it's 2 to the minus 3 to x plus 1 equals 2 squared to the 5x. So it's 2 to the minus 3x minus 3 equals 2 to the 10x. Same base, so the powers must be equal because they're equal. So negative 3x minus 3 equals 10x. Add 3x to both sides. And we get negative 3 equals 13x. X equals negative 3/13.